Future House just launched 4 highly specialized AI agents, and they're free to use right now. Backed by Schmidt, former Google CEO, this isn't some private beta. It's public, powerful, and already outperforming PhDs on key research tasks that are called Crow, Falcon, Owl, and Phoenix. Each focuses on a different piece of the scientific workflow, from answering complex technical questions to designing brand new molecules. Tasks that used to take weeks, now completed in minutes. Let's break it down. The platform. First, what makes this platform different? Future House says each agent was built for science from the ground up. No casual chit-chat here. Crow is your quick response generalist. Ask a technical question, and it scans open access papers to give a concise, citation-backed answer. Falcon goes deeper, pulling in dozens or even hundreds of full-text papers, plus private databases like open targets, crafting long-form reviews. Owl, renamed from a prototype called Has Anyone, works like a detective checking if someone has already done your experiment, so you don't waste 6 months reinventing the wheel. Phoenix is still experimental. It's the chemistry specialist, proposing new molecules, predicting reactions, and even calculating whether it's cheaper to buy or synthesize each compound. You can even chain the agents together, allowing a single researcher to handle workloads that used to take entire teams. Why this matters? If this sounds familiar, it's because Google's AI for Science tried something similar earlier this year, but ran into problems. Remember Google's much-hyped 2023 genome system? It claimed to discover 40 new materials, but later reviews found none were actually novel. That failure highlighted a big issue. AI hallucinations can derail scientific discovery. Future House is working hard to avoid that. Every answer includes transparent reasoning and multi-step evidence trails. You can click through each step to see how search terms were chosen, how journals were ranked, and why certain papers made the cut. For example, in one demo, Falcon reviewed 32 papers, picked 24 as highly relevant, and distilled 62 evidence chunks into a final answer. You, the user, can inspect every part of the process. That's a big deal because, let's face it, scientists are skeptical by nature. Solving real problems. Future House openly admits that today's large language models can't handle high-precision tasks alone. They even struggle to count atoms reliably. So Phoenix connects to external chemistry tools, pattern databases, solubility predictors, reaction simulators. Basically, it's an LLM with a calculator brain. They also run their own wet lab in San Francisco, letting them test hypotheses, synthesize compounds, and feed real-world data back into the models. This feedback loop is key to improving the system. The 4-layer architecture. Here's how the whole platform works. Base layer standard. AI tools like Alpha, Fold. Agent layer assistants like Crow and Falcon handling tasks. AI, scientist future goal, design complete experiments. Human researcher you, the person asking the big questions. Humans remain in charge of what matters. The AI handles the grunt work. A real-world case, PhDs. To prove this isn't just hype, they ran a test tackling polycystic ovary syndrome, PCOS. Michaela Hinks, head of their science team, started from scratch with no PCOS background. First, she asked Falcon for a full breakdown of PCOS definitions, symptoms, causes. It pulled together studies and clinical trials, filtering duplicates and ranking sources by quality. Then she switched to Crow and asked which genes are linked to PCOS. Crow identified key genes like DND1A and cited multiple studies. Next, she used Owl to see if anyone had already connected those genes to hormone disorders. One study had, but the mechanism wasn't clear. That revealed a research gap in just 4 prompts. What would normally take a weekend of reading was done in minutes. Finally, she turned to Phoenix. She asked it to design 3 new compounds that might regulate the gene in question. Phoenix analyzed possible drug targets, cross-checked patterns, predicted solubility, and even estimated the cost of synthesis. It created a full report for each option. Tasks that would normally take weeks or even months, done in a single workflow. Benchmarks and transparency. Future House tested their agents against top literature search models, plus human PhDs. On precision and accuracy, their AI topped the charts. They didn't publish raw percentages, but the claim is clear: superhuman results in key areas. Phoenix is still new and may make mistakes, but the team encourages public feedback and rapid iteration. No one's pretending it's perfect. Scaling up. Here's why scale matters. PubMed has over 38 million papers. Clinical trials. Golf tracks 500,000 trials. Scientists use thousands of siloed tools. Most labs simply can't process that much data alone. Future House wants to be the infrastructure layer, offering API calls so that labs can automate literature reviews or contradiction checks overnight. Everything is free to use and open to feedback. Key parts of the platform are open source. The skeptic's view. Of course, not everyone is convinced. As TechCrunch pointed out, Future House hasn't yet produced a truly novel discovery. No new drug, no breakthrough material. Even Google's genome team failed to deliver on that front. Future House says the issue isn't just algorithms, it's also real-world experimental bottlenecks. That's why they have a physical lab to close the gap between theory and practice. The vision. In the next few years, Future House believes most scientific discoveries will have an AI-driven component, whether during the literature search, the data analysis, or both. Their long-term goal: an autonomous AI scientist that can read every paper in biology, spot contradictions, propose hypotheses, design and execute experiments, evaluate results and iterate. Humans will remain the decision makers, judging significance and ethics, but AI will handle the heavy lifting. If successful, they say this could unlock thousands of missed opportunities buried in research papers nobody has time to read. Ethics and risks. The team emphasizes open source development and transparent reasoning to reduce risks. But they also acknowledge that hallucinations, bias, or errors could still occur, especially in complex chemistry tasks. They're betting that openness plus community feedback is safer than closed-door AI. What's next? In the short term, they want the platform to analyze raw lab data, not just published studies. Imagine an AI that watches your latest RNA sequence results and immediately correlates them with millions of prior experiments. Long-term, they hope to dramatically increase scientific productivity, overcoming the stagnation that's plagued research for decades. You can try it yourself at platform.ho.io. Sign up for free. Query Crow. Run Falcon. Let OWL check your ideas. Ask Phoenix to propose a new molecule. If these tools can even cut 10% of the manual work, they could be a game changer. And if Future House's full vision succeeds, we might soon tell future scientists stories about the dark ages when we had to read every paper and crunch every p-value ourselves. So, are we about to see AI outperform top researchers and take the front lines of discovery? Let me know your thoughts in the comments. Smash like if this saved you hours of reading. Subscribe for more, and I'll catch you in the next one.